Hello everyone, and today in our lecture we will learn about vectors. So why vector is basically a data type in which we store which provides us dynamic sizing, efficient random access and versatile data storage, making them invaluable in programming. So it basically array like data structure where you can like store numbers, anything we want to. So to declare a vector, we like first have to include the header, which is vector, just the name vector. After that we declare it by using the keyword vector, and then these small in these operators, and then we put the int or string or anything we want, and then we put the name. So how we put elements? Now you would ask, if we have declared that we have included the header, now how do we add elements onto this vector? So we could do a thing where we just go ahead and vector int numbers. Actually, why I have written over here, let me just add on to it, and then we go 1 2 3 4 5. We could do the same as the arrays, or we could use a predefined function that is in our this declared in vector header, which is the name of the header, the vector. Then we have the pushback function. We call this function from the vector header. So we use this, or there's another and place back. These are the ones we use in putting the elements into our vector. We have to put the elements like in a particular order, like 1 2 3 4 5, or 0 1 2 3 4 5, like how in arrays we put some things. So after that, if we want to like remove, for example, we have made a mistake in the thing and we want to remove an element. So for that we use numbers dot pop back. Basically it kinda just deletes the element. We use only this to remove the last element. Basically it's going to remove 5 from the vector. It removes 5 from the vector. If we put it above this over here, it will remove 4 from the vector, and then 5 would be in place of 4. So this is how push back and pop back works. So after that we have how we can access these elements. Okay, so to access the elements, I have made a for loop over here that goes through every element of the array of this vector, and then just displays them after every one space. It's very similar to the how we access arrays, like I have told in the one of the previous lecture on single dimensional array. There we do the same thing. We just basically make an integer I that is equal to 0, I less than numbers, and this is a function from the, let's see which is from the vector header, which tells us the size of this vector, and then vi plus plus see out which number of element it is. So this is how we access the members of the vector. So the size and capacity, we saw the size. This is how you check the size. Let's make a console out that shows us the size numbers size, and like this it will display the size. Okay, so let me put it after this. It would be look much cleaner. Okay, so now if we want to display the capacity of the our vector, this is how we use. See the capacity, this is the size function, this is the capacity function. It basically does it things on your own. They are specified in the vector header. So if we want to, like, after this there's another thing that we can do to vectors. If you want to resize, they can be resized dynamically. All we need to do is use a function named resize, and then we can change it to as much as we want. Like if I want, I can do it to 10, and then is that this would be the new size of the vector. So let's run this code and see what we get. Okay, so elements in the vector, we get that. After that we have our size. I should let me do a few changings like this. Okay, so it like displays on different lines rather than being mashed in together. Okay, so as you can see, we got the size, which is now 5. The capacity of the vector is 8. Basically it can store 8 elements for now. Then we like do the element at number index 2, which is 3 basically, because it was like 0 1 2, so this would be 3, and then in 4 it was 5, which is the last one. Then after that we change the, like after the capacity function call, we change the size into 10. So the size of the vector changed to 10, and then we got the numbers size. This is how you can make your own vector, change it a vector, add on to the vector, and delete if you want to. So why are these used? Vectors are basically very ideal for dynamic collection, list, or when the size is unknown in advance. Basically to, like, over here if you see, we didn't put any, basically we like declared and initialized the vector. We didn't put any size of it, like what size the vector is going to be, what size, like how many elements are there going to be. We didn't tell the compiler. It just made the vector of size 8, of the capacity 8 and size 5. Okay, so it can be useful over the arrays. So we can, like, if we don't know how big the list is going to be, we can just make vector and then just put the elements, keep putting elements inside of it without having to worry about how big the vector is going to get. It wouldn't really matter for us. Like for example, you make a program which helps you like remember the list of all of the shopping items that you want to get. For example, if you may have used an array and like you had a like a array with the let's for say 20 items, but then you remember that you have to add another one. You're gonna have to go through the code and write change it to 20 and then add again and all that. So instead of doing that, we just make a vector just to, like, for future change, if you want to change it the future and add more. But if you want to keep it static, as you can, it is better to use arrays. So these vectors are very efficient random access, but it may occur reallocation cost when resizing. When we resize it may cost our reallocation. So the reallocation of memory, it will reallocate the memory right after we resize it. So basically what it means, like before, like we resized it to 10, its size was 5, So it memory was like, for example, it was given 5 bytes of memory, okay, before. Then after that we gave it 10 bytes of memory. So this is how like reallocation costs occur when we resized it. So this is how vectors in C++ work, and this is how you can declare and use vectors and make your own vectors. So this was all for today, and I will see you in the next one.